and that is on page 322. We are given the following graph. You're going to see this function in chapter 4. I'm not going to even name it right now. So here's the graph. I'll tell you then what it is. But I'm going to copy the points that we see. Can anyone give us the points so I can copy them?
0, 1,
Perfect. 0, 1. Anything else?
1,
Negative 1, 2.
and negative 2, 4.
Excellent. That's all I needed. Thank you very much. I'm going to copy them. Good. So this was 0, 1. This one here was negative 1, 2. And there is another one at negative 2, 4. First of all, first question, is this a function? Yes. So number one, we know function, since it passes, careful, the vertical line test. It is a function because it passes the vertical line test. Awesome. Number two, is this function 1 to 1? 1 to 1 since?
Horizontal.
Exactly. It passes the horizontal line test. Very good. Number three, graph its inverse. I should have asked, does it have an inverse?
Yeah.
Why?
Because that's a
Because it's 1 to 1. Awesome. Excellent. Thank you, both of you, Jody and Mana. Wonderful. Great. So then I would like you to give me some points so I can graph it. Remember, let's also write number 4 as a reminder. The graphs, so I'm going to call this function f of x. The graphs of f of x and f inverse of x are symmetric. WRT, you know, lazy people write with respect to, as WRT, with respect to the line. It was done quick, it was done last time, that's why I wanted to start with another problem. Excellent. Thank you, Jody. Good, here it is. I have to graph it. Absolutely. Because I want to graph both the function and the inverse on the same coordinate system. Otherwise, I wouldn't do it, right? Okay, can anyone give us some points that I need to plot to graph the inverse? And how do we do this?
0, negative 1.
Say it again.
0, negative 1.
Say it again.
Negative 1, 0.
No. I can't change anything. I can only reverse them. One more time. If the function takes 1 to 5, the inverse will take 5 to 1.
So 1, 0.
Exactly. Excellent. Here's what has to happen. You don't have to draw this. This distance between the point and y equals x has to equal this distance on the other side. They have to be symmetric with respect to the line y equals x. So this point must be 1, 0. Now, can you tell me whether this point will be part of the other graph? Yes, because if it's 1, 1, reverse 1, 1. All points on this line are 1, 1, 2, 2, 3, 3, 4, 4, x equals y. So if the function crosses at this point, the inverse must cross at the same point. Because all points here have the same y and the same way, as the same x. If you try to reverse it, it's not going to make any difference. Still the same. Good. Give me another point, please.
2
Yes?
to negative 1.
Excellent. 2, negative 1, right here. Good. One more, please.
4.
Exactly. 4, negative 2. Excellent. This is the graph of F inverse. And remember what has to happen. This piece has to overlap this one. This piece has to overlap this one. Of course, my graph is not perfect, but it's clear that these two are symmetric and these two are symmetric. And you can say not perfect, and I would definitely have to agree. Okay, any questions? Any questions on this? Yes, please, Mana.
This is what you just showing us
How to graph the inverse
Inverse.
function of a one-to-one function once the function is given. I'm only reversing the order pairs. If I have 2, 5 for f of x, then I have 5, 2 for f inverse. This is a list of services, free services that the college is offering. Okay, next and final section from chapter 2, 2.8. Any questions? Stop me if you have anything. Any questions? Okay, 3 things in 2.8. Distance, formula, midpoint, formula, or definition, or just point. And the last one, the circle. Or you can write the equation of the circle. Of a circle. The equation of a circle. So let's start with the distance. Let's suppose we have 2 points. Here's the coordinate system. Here's point A, and here's point B, and I would like to determine the distance between those two. You can just call it D, or you can call it D sub AB. It's up to you. The equation of a circle. So the distance formula, the midpoint formula, and the circle, or the equation of the circle. So you can denote it by the distance AB or simply the distance. This point A, since it's our first point, I'm going to denote the coordinates by x1, y1. Why do you think I'm going to denote the coordinates of B? Right, makes sense. So obviously, this piece is what? How much? No, it has to be x1. There is no guess. So what is this piece? Absolutely, no guess. Okay. No, we are talking about the general situation. So what will this be? Once I put x1, y1, I cannot say all of a sudden that this is 5. Otherwise, I would have put 5, whatever. So what is this distance?
X2.
Very good. And obviously, what is this distance? Very good. We're going to form a right triangle. This is parallel to the x-axis. This is parallel to the y-axis. So we form the right triangle, which is this. And we know we have a famous, or we use a famous theorem in a right triangle. But first, can anyone give us this distance, or the length of this leg, and this distance, which is the length of the other leg?
y2 minus 1.
Of course, for the, yes, y2 minus y1. y2 minus y1 is this distance. Very good. And this one?
So it'd be x2 minus x.
Perfect. So the Pythagorean theorem The Pythagorean theorem says the distance squared, which is the hypotenuse squared, equals x2 minus x1 squared plus y2 minus y1 squared. We know this from a long time ago. Now, I don't want you to say ever, when you talk about the Pythagorean theorem, I don't want you to say a squared plus b squared equals c squared. That doesn't mean anything. You have to identify which ones are the legs. So if I tell you here, a squared plus b squared equals c squared, what am I telling you? Nothing. I have to say one leg squared plus the other leg squared equals the longest side squared, which is the hypotenuse squared. This is what I have to say. Don't say it a squared plus b squared equals c squared. No one will understand what you're saying. Is that clear? Perfect. So this is the distance formula. However, we will take the square root from both sides. When I take square roots from both sides, what do I have to present? Always, forever. Plus or minus. However, we're talking about a distance. This one time, I will not write plus or minus, but just plus. So the distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. Can we simplify it?
Yes.
The answer is no, of course. We cannot take the square root from a sum. So let's talk about this because this is very important. I can take the square root from a squared times b squared, which is the square root of a squared times the square root of b squared. I can do it for a squared over b squared, which is the square root of a squared over the square root of b squared. But I can never do it for the sum or difference. There is nothing here. Nothing. So therefore, no one can touch this. No one can further simplify it. No one can do anything to that. This is it. That's the distance formula. Now let's look at the midpoint formula and then choose a point, 2 points. I'll ask you to choose any points you want. So what is the midpoint? Is a point that divides, we say bisects, any segment, any line segment into 2 equal parts. And this point is denoted by uppercase M, midpoint, the point that is right in the middle. So the coordinates of the midpoint are 2 ratios. The denominator in both cases is 2. x1 plus x2, the sum of the 2 x values, and the sum of the 2 y values. It's the average of those values, basically. So now let's practice this. Please give me 2 ordered pairs, any ordered pairs you can think of. Or if you want to choose them from the book, please choose them from the book, whatever you want. So just give us 2 ordered pairs, and we will determine the distance between those, and we will determine the midpoint, the coordinates of the midpoint. Any?
2, 4.
Perfect, 2, 4. Put a negative in there in any one. Doesn't matter which one.
-1 and like 2 negatives or just 1 negative?
It's up to you.
And 8.
Perfect, excellent. So we have 2 points. We want to determine 2 things. Let's determine the midpoint because it's the easiest that we determine right away. And then we will determine the distance between those 2. Remember the midpoint. We're adding the 2 x values. When I add 2 to -1, I get?
1.
Good, 1/2, done. We're adding the 2 y values. When I add 4 to 8. Yes, it's 12 divided by 2 is 6. Done. So that is the midpoint. Now let's determine the distance. I highly recommend write x2 minus x1 everything squared plus y2 minus y1 everything squared. And like I like to do with the line, I recommend the same thing here. It's up to you. I will say this is my x1, y1, this is my x2, y2, and I will write them underneath. -1 and then 2 and then 8 and then 4. this is easier for me. It doesn't have to be easier for you. You choose the method that is easier for you. So then the distance is the square root -1. Now you understand that whatever I get in here, I square them and I add. So obviously you will never write that the distance is the square root of -47.
Right.
That's never going to be the case, right? Because whatever we have, we square and it's positive, right? So this will never happen. Agreed?
Yes.
Okay, perfect. So how much is -1 minus 2? And when I square -3, I get 9. So let's write it directly as 9. Then 8 minus 4, 4. And I square that, so it's 16.
Okay, that worked out really well. That's
Very well.
nice.
Remember, this is not the square root of 9 plus the square root of 16. Be very careful. This is the square root of 25, which is 5. You couldn't have done better. Excellent.
It was
Ex-
random.
Well, it worked.
Excellent. Excellent. Maybe you should get a lotto ticket. Okay, this is it. So for any pair of ordered pairs, we can determine the midpoint of the line segment connecting them, and we can determine the distance between those 2 points. Do you think we need other examples, or is this clear?
Pretty clear.
Do we need other examples?
Repeat the middle again, like how did you get again?
2 plus -1 is 1 divided by 2. And then 4 plus 8 is 12 divided by 2. The average. Are we okay with this? Okay, then. So the last thing here, this circle. Bear with me and say that this is a circle. I know it's not. Far from being perfect. But the center of the circle is denoted by h comma k by convention in several books, not in all. So let's stick with h comma k. And this, obviously, must be the radius, lowercase r. And let's all points on the circumference, any point here, will have coordinates x comma y. A, x comma y, corresponding to the point. Okay, so what do we see here? I see a point with coordinates x comma y, and I see a point with coordinates h comma k. I see that the length of the line segment is indeed r. We just discussed something very similar, in which this is the radius squared. This is x minus h. And then this is y minus k. That's all I have to do. So let's write the equation of the distance formula first. Let's look at it with the one with the squared. So x2 minus x1 squared plus y2 minus y1 squared. And now let's replace all these with the information we have. What will you replace d squared by?
R squared.
Perfect. What will you replace x2 minus x1 by? And of course, the squared.
H minus.
The other way around. It's not a mistake. It's the same thing. But we like to put x first. It's the same. X minus h. And then
Y minus K.
y minus k. This is the equation of a circle. With center C, h comma k, and radius r. This is the equation of a circle with center C, h comma k, and the radius r. There are 3 types of problems here, from the easiest to the most difficult. So let's write the formula one more time. X minus h squared plus y minus k squared equals r squared. And let's discuss something or a few things here very important. This has to have x in it and squared and plus. This piece has to have y in it, not necessarily k, because the center can be on the x-axis, it can be at the origin. So these may be there or not. But x must be, y must be, the square, and the number on the other side. This number must be positive. Of course. Because if it's 0, what is the radius? Is that a circle? It's just a point. Right. Can it be negative? No. The length of a or a distance or a radius cannot be negative. Right. What else we notice? We notice that there is a minus between these two. And there is a minus between these two. Okay? So here's the first type of problem here. Given the center, negative 2, 0, and the radius 4, find the equation of the circle. And graph it. This is the easiest type of problem in this section.
Find the equation.
Find the equation. So given the center and the radius, find the equation.
So we would plug in
That's
the
it.
points for the center and the
That's it.
board for.
There is
Well,
nothing.
we'd have to. Well, you could put
So I will
points
write what x.
plus 2.
Excellent. Plus
Y minus 0.
which
so
is
y squared,
excellent equals
4 squared.
which is
16.
that's it. This is the equation of the circle with center negative 2, 0 and radius 4. That's it. Let's graph it.
Why is y yeah, why? Because if you put y to 0, okay, done. Alright.
That's okay. That's okay. I love it when my students answer to my students' questions. That is my ultimate goal. Good. So I have to plot the center, which is negative 2, 0. Here's the center. And the radius of 4 units. So one more time, please look for a second and see what I'm going to do. So here's the center, and I'm going to plot a point 4 units away to the north, a point 4 units away to east, a point 4 units away west, and a point 4 units away from the center south. So 4 units, forgive me. 1, 2, 3, 4. 1, 2, 3, 4. 4 points. 1, 2, 3, 4. Don't be surprised that my graph is not going to be perfect. Please don't be surprised. But just bear with me, smile, and say, it's a circle. I know it's not. So, negative 2, 0. Now, what if I ask you, is this a function?
No.
Of course not. By the vertical line test, it cannot be. Does it have a domain? Yes, it does. Does it have a range? Yes, it does. So please give me the domain of this relation, and please give me the range of this relation.
Would the domain be negative 4, 2?
So I'm in negative 2 already. So this must be
-6.
negative 6 to 2. Very good. So negative 6 to 2, I agree. And negative 4 to 4, I agree. This is the first type in which we are given the center, we are given the radius, we're asked to find the circle, the equation of the circle, and the graph it. Here's the second type of problem in this section of. Given x plus 3 squared plus y minus 2 squared equals 4. State if it is a circle and why. If it is, find the center and the radius.
It is a circle.
It is a circle because I compare it to the general equation. And I see some completed square with x, some completed square with y, and a number on the other side. So therefore, this is indeed a circle, and that's how I explain why. It matches the equation perfectly. Therefore, I can find the center. I can identify the center and the radius. And the center is?
-3, 2.
Very good. And before you ask why -3, remember, there is a negative in the formula. And the negative in the formula, that's why I pointed out. So if I have x plus 3, that really means x minus -3. That's why h is -3. What about the radius? Excellent. Exactly. The square root of 4 and it's 2. Very good. And here's one more type. Last type, number 3. And I cannot make it up on the spot, so I'm going to ask you to choose a problem, or I will choose a problem. On page 332, anything you want from 53 to 64. And this is the last problem of chapter 2. One, two, three, fine. 58. 58, x squared plus y squared plus 12x minus 6y minus 4 equals 0. Okay, so bless you. What is the requirement here? So x squared plus y squared plus 12x minus 6y minus 4 equals 0.
You have to get them in the correct format.
Exactly. Is this a circle? I can write circle today. Is this a circle? My answer is no clue. I have no clue. If I do my magic and I change this equation into this, I'll say yes. If I do my magic and I cannot change it into this, I'll say no, it's not a circle. So what do you notice here again? What is this? A completed square with x. What is this? Right. So then, do you remember one of the 4 methods of solving quadratic equations in which for one of them I said, but it has use for something else? Which one was it? Exactly. So, I will look at this, I will look at this, and find something that it needs, that these two need to complete the square. How do we complete the square? The middle coefficient is 12. We divide it by 2, 6, and we square 6. So we're adding 36, and it has to be to both sides. So this piece, and this piece, as our first day of classes, I hope you remember, these 3 terms are here. What do I put in here? So that when I expand those, I get this, this, and this.
X squared plus 6.
Not x squared, but just x plus 6.
Sorry.
Excellent. Now, I do what? I repeat the process for what?
Y.
Exactly. So this and this. This was -6. -6 divided by 2.
-3
Yes, -3 squared.
makes 9.
So I need to add 9 to both sides. Now this, and this, and this, plus, don't forget the plus, are here. What is this?
Y minus 3.
Very good. Equals. Now let's account for what we have not used yet. Exactly, awesome. I did not use -4, which goes to the other side. I did not use the 36, and I did not use the 9. What do we have on the other side?
49.
Excellent.
Oh, and it all goes up.
So, is this now the equation of a circle? And you can say, wait a minute, I don't know. Give me a second. Yes.
I have a quick question.
Yes, don't forget what you want to say. One second. Yes. Yes. Plus between equal symbol and a number. Yes.
If we had to add 36 and 9 to each side, where did the 36 and 9 from the left side go?
Thank you. There are 3 terms in here. First day of classes.
Right, but why did we add it to both sides then?
So if I have
Normally, it would be x squared plus 12x.
if I have a balance and I have 1 page on this side and 1 page on this side, and if I put 5 pages here,
I understand balancing it out. I just don't see what happened with the 45 of the left side.
Get x plus 6 squared without the 36 on making our trinomial out of x squared
Oh,
plus
okay,
12x.
okay, that makes sense. Okay.
right? Remember, first day of classes. X plus y squared
I think it's
equals
just 'cause
x
it was
squared plus
simply both
2xy.
on top of each other instead of just the one I think it just looked like it looked weird.
Right. I just wanted to review this, right? So 1, 2, 3, this, and this are all here. Then this, and this are all here. So now this is left over, this is left over, and this is left over. Everything else is accounted for. And that's how we get the 49. So is this the equation of a circle?
Yes.
Can we now identify the center and the radius? That's why I tortured you with that method of completing the square. Just for this. Why?
Because it's easier.
Because it's the only way to identify the equation of the circle. Number 2, it kind of works in solving quadratic equations, but as you know, not alone. Not alone. But we learned it then, so we don't have to spend time now. So, yes, one more time, please give me the center.
Negative 6 3.
Very good.
The radius is 7.
That's it. Perfect. Any questions? Please choose another. I think we need another example like this. Yes, please.
How did you find the center? Is that what we're going to see?
The center is, I have x, I have positive 6, so that it means that h is negative 6. I have y, so then k is 3, and the radius must be 7. By comparison to the general equation.
Okay.
Is that better?
No.
So is it clear why k is 3?
Yeah.
I have y minus 3, y minus k. Is that clear why k is 3?
Yeah.
But I remember here, x plus 3, I wrote it as x minus negative 3 because I have to have a minus. The formula has a minus. So that's how we get the negative 3. And that's how we get a negative 6 here. Is that better?
Yeah.
Perfect. Excellent. Yes, please, Steve.
May we review 64?
Yes. So, you want to do 64?
Yes, please.
Of course. So x squared plus y squared plus 3x plus 5y plus 9/4 equals 0. And this is problem 64 on the same page, which is 332. Perfect.
This is like
Another example with the same question. Yes, sorry about that. I should have mentioned. Another example with the same question. Is this the equation of the circle? And the answer is I have no idea. The way it looks right now, it can be. It's a 50-50 chance. Maybe, maybe not. How do I start?
You look for your complete the squares.
Exactly. So we try to complete the square. So let's start with x squared and 3x. The middle coefficient, 3. 3 divided by 2.
3/2.
3 halves. 3 halves squared.
9/4.
Oh, awesome. Excellent. So these 3 are here.
So we're not going to move the 9 over 4 over, because that's our.
That's why I don't want to start by moving, because it may be what I need. So it just happens that it's what I need.
So it'll be 3 halves, right? X
Yes, plus 3 halves. Plus. Now I continue with y.
Wait, 3 halves? Oh, wait.
Good. So now let's look at this. The middle coefficient is 5. 5 divided by 2 is 5 halves. I square 5 halves. 5 over,
4.
yes, plus 25 over 4 plus 25 over 4. Now these 3 are here.
Wait, I don't understand why 3 halves.
Say it again.
2. I don't understand why it's 3 over 2.
In here? Okay. First term squared plus 2 times the first times the second plus the second term squared. 3 over 2 squared is 9 over 4.
Did we do the first one as well?
It happened that we had a 9/4. It was there. There is no point in adding 9/4 to both sides if I already have it. Good. So then here we have y.
Plus 5 halves.
That's it. Not squared, but just 5 halves.
I meant like.
Right, yes, because y squared is this, plus 2 times the first times the second is this, plus the second term squared is that. What is left on the right-hand side?
25 over 4.
That's it, nothing else. Now, we are asking ourselves that question again. Is this a circle? Yes. What is the center and what is the radius?
Negative
3 halves.
and negative 5 halves
And the radius?
is 5 over 2.
That's it. Yes.
So you just divide by 2 and then you find the square root of whatever it is.
You mean, you're talking about this? Or you're talking about the radius?
So like when you get 3 over 2 from 3, you're just dividing the 3 by 2.
Yes.
And finding the square root of one of
I have to square it to add that number to both sides.
Okay.
So one more time, the method of complete the square, identify the middle coefficient, 3.
Yeah.
Divide 3 by 2.
Uh-huh.
Square that number. Add 9/4 to both sides.
Okay.
In this case, it wasn't necessary because I already had the 9/4.
So then you just don't add.
It just happened.
Okay.
It's there. So then these 3 are here.
Okay.
So this is accounted for, this is accounted for, this is accounted for. They're all 3 in this first piece. Yes?
So if you did the 25 full, how did you take that?
So the middle coefficient is 5. I divided by 2. I square this, 25 over 4. And I add 25 over 4 to both sides. Is that okay? Yes? Good. Yes? Any questions? Chapter 3. In chapter 3, we're going to look at polynomial functions, rational functions.